Yeah.
Right. So sorry, we are back again. All right, moving forward. So now, introduction to programming. You know, while we were talking, we talked about the coding or implementation stage. So at this step, you need to use a particular programming language to solve your problem. So when we are talking about a computer program, computer program is a sequence of well-defined and logical instructions written in a programming language to solve a particular problem or perform a specific task. I know most of you have heard of a programming language before. You have even worked with several programming languages. It depends on what you have done in the time past, but I know that programming language is not entirely new to most of you. So when we are talking about programs, there are step-by-step instructions that you give. Okay, when you give someone an instruction, you are giving someone a program. Just like when you're calculator. Calculator has been programmed to perform particular mathematical functions. All right, so we have several examples of computer programs, calculator software, word processing application, mobile apps, websites, any software you want to think about has been programmed using a particular programming language. And also, every hardware that you see is controlled by a particular program set of instruction. That is why sometimes when you sweep through your devices, maybe your smartphones, and you click on message, there's a particular response that you give. That means it has been programmed to give that particular response. You can't be on message and it's giving you an output for maybe contact. No. So every software has a particular program that it runs with, and it has been programmed in different or a particular programming language. It's not compulsory that you use just one programming language. It depends on the one that you are efficient with. All right, so I will want to call the attendance code 2 now. Please listen attentively. So the attendance code 2 is Q U X, X for X-ray, L for lion, then Z for zebra. So the second attendance code is QUXLZ. QUXLZ. I hope you have taken note of that. All right. Yes, sir. Second code is QUXLZ. QUXLZ. All right. Okay. So even your automated teller machine ATM, it runs on a particular program. Anything you see, it works on a particular program. All right. Now, we have talked about a computer program being a sequence of instruction that's been given to a computer, that it has been written in a particular programming language and given to a computer to perform a specific task. Now, programming, there's a change in part of speech. So programming is the process. Programming is the process of designing, writing, testing, and maintaining programs that instruct a computer on how to solve problems or perform tasks. Since program is a sequence of instruction that has been given to a computer, programming is the process of writing it, of designing it, of testing it, and maintaining the programs. All right. So programming involves logical thinking and problem-solving skills to convert human ideas into instructions that a computer can understand. We are in the jet age. And when I'm talking about computer, I'm not necessarily saying a laptop, because computer is an electronic machine that accepts data, processes, and gives out an output. So any system that you have that takes in an input, that processes it and gives an output, is a computer. Do you understand? All right. So it helps humans communicate with computers effectively. You know, there's something we call human-computer interaction. It's very important. There are some of you that you interact with your digital assistant. You can just say that, Alexa, do this for me, do that for me. You know, you communicate. It's the programming language that's been used for coding that enables that free communication, because the computer has its own language and we also have our own language. So programming languages helps us to be able to bridge that gap between humans and computers. So a programming language is a formal language that is used to write programs. It consists of a set of rules, symbols, and keywords that programmers use to create instructions for computers. So a programming language is a formal language used to write programs. If you're saying that you're writing a particular program, that means you are using a particular programming language. So it acts as a bridge, just as I said earlier, between human logic and machine execution. Now we have types of programming languages. We have the low-level programming languages and we have the high-level programming language. Now, when we are talking about low-level programming language, these are languages that are very close to the hardware of the computer. They comprise machine language and assembly language. These are low-level language, but machine language is the lowest level language, is the native language of just like now, if peradventure you are giving birth to by Yoruba parents and you stay with them, your native language is Yoruba. You're able to interact with them conveniently with Yoruba. Other languages, you might not be able to understand them. They are not your native language. But that Yoruba is your native language. So the what we are calling machine language is the native language of the computer. Is what the computer understands without difficulty, any difficulty. So this machine language consists of zeros and ones. They are binary digits. That means even when you say that okay, Alexa, do this, it's translating it to series of zeros and ones. If you are switching on a computer, pressing that button is translating it to series of zeros and ones to activate a particular function in the system. All right. So machine language is the only language that the computer understands directly without any form of translation. It is executed very fast, but it's difficult for humans to understand. Now, if you want to give a particular order or command to a machine, and you have to start saying 0001111101000. Maybe what I've just said is just representing maybe go. Can you see that it's very, very complex? So that is why it's extremely difficult for humans to understand machine language. Now we also have what we call assembly language. Assembly language is a low-level language. It uses symbolic instructions called mnemonics. Now, these mnemonics are abbreviations of words. You know, every system has its own architecture and has its own instruction set. Now, this assembly language is a little bit close to the computer, but not as close as machine language. So this assembly language, they use mnemonics, which are symbols, just like MOV for move, add ADD, subtraction SUB. Do you understand? So, but they are also not very easy to understand because they also require deep knowledge of computer architecture. You need to know all the instruction sets of the hardware, and it's very, very cumbersome. So that is why assembly language also has its own level of difficulty. It's not easily understood by humans, but it can still be understood by computer, by machine, when you use an assembler to convert it. All right, so we have high-level programming languages, and these are languages that are closer to human language and much easier to read, write, and understand, because most of these words that are being used, they are words that are easily understood, English words. You understand? So these high-level programming languages, they allow programmers to focus more on problem solving rather than hardware details. You don't need to start looking for the instruction set of a particular hardware Whereas you need to look for a way to solve a particular problem. So when you know the way to solve a particular problem, all you need to do is to format it using a particular programming language. You program it, you code it with that programming language, and there you are, you have your solution. So these languages are portable, meaning a program written on one computer system can run on another system. You don't need to start changing system architecture. You don't need to start saying, okay, this CPU, this is the type of CPU that this one has. No, you don't need it. It runs on any system, no matter the architecture, with little or no modification. Now, high-level languages, they require translators. I said earlier that the native language of machine is of computer or system is machine language. So you need all right, you need translators such as compilers, interpreters, or assemblers. So we are going to get the many of those ones. So examples of high-level languages are Python, Java, C, and the likes. We are very conversant with that. Most of us, we are programmers, and one way or the other we've used one or two of these programming languages or even more. So these are high level programming languages. Now, when we are talking about language translators, they are system software that convert programs written in high level or assembly languages into machine code. Language translators make it possible for programmers to write programs in human-friendly languages. They help you because they stand as intermediary. Like, take for instance, if you travel to a French-speaking country, you might not be able to understand their language, which is French. Now, there will be someone that will interpret. Maybe if they say "comment tu t'appelles," they will interpret it and tell you that, okay, this is the meaning in English. Do you understand? So this is what translators do. When you give a system a particular command, it's those translators that will turn into zeros and ones for the machine to understand. Now we have types of language translators: their assembler, their interpreter, and their compilers. Now, assembler is a translator that converts assembly language program into machine language. It replaces mnemonic instructions with their corresponding binary codes. So, assembler works to convert assembly language into machine language. We also have interpreter. Interpreter and compiler, they convert high-level programming languages to machine language, but the way they work differ. Now, interpreter is a translator that converts and executes a program line by line. It translates one statement, executes it, then moves to the next. If an error occurs, execution stops at that line. Now, if you are coding using Python, you discover that, let's assume your fourth line of code is print hello world. Then your next line of code, there's an issue with it, and the one next to it is maybe print hi. Now, your Python will give hello world and we now give the error code downwards because it's a line by line execution. So that's how an interpreter works. An interpreter will convert and execute a program line by line. So when it meets an error, it stops. All right. So examples of interpreted languages include Python, JavaScript, and R. Now we also have compiler. This is a translator that converts an entire high-level language program into machine language at once before execution. Now, it goes through the code, it runs through it and checks from the beginning to the end. If there is an error, it will not even execute the code at all. So that's the difference between an interpreter and compiler. Interpreter will execute a program line by line, while a compiler will convert an entire programming language into machine language at once before execution. So it does that, and whenever there's an error, it will not even execute it at all. All right, so I'll be calling out the attendance code 3 now. So attendance code 3. Listen attentively, please. Attendance code 3. 77 DE5. 77 DE5. Now submit. Submit now. I want you to submit. Submit now. All right. So thanks for your attentiveness and your attendance. So this is the end of the class. Thank you. Have a blessed day. Bye.